So hello guys, what's up? We are back again with another question from our level up series. And this question was asked in today's contest. This is block placement queries. So this is a good problem, and in fact a very good problem, such that only 2.6% people could answer it in the contest. So yeah, now let us understand what this problem is all about. So in this problem, we are given a vector of vector queries. That is, we are given a query matrix and we need to find out, based on some conditions, we need to find it out. We need to return a vector of bool, that is a Boolean matrix. So let us see what the question states. Now, in this question, we are given a query matrix, and in that query matrix, there are two types of queries, query 1 and query 2. Now, query 1 consists of placing an obstacle at a distance x, which is given in the question. So, in this question, we will be given, let us assume that we are given some number line. Okay, so this is 0, this is 1, this is 2, this is 3, this is 4, and so on. So, we will be given a x, that is a distance at which a block will be placed, and let us say this is origin. Okay, this is of type 1 query. Now, what is type 2 query? Type 2 query states that we need to place a block of size x. We need to place a block of size sz anywhere in the range 0 to x. That means if x is a, consider x as a coordinate. So from 0 to x, you have to place a block of size sz if it is possible. So if it is possible, you have to return true. And if it is not possible, you have to uh, add false for that particular value in the answer. So one thing which is very important is that a block cannot be placed if it intersects with obstacle. It may touch it. Note that you do not actually place the blocks. That means the queries are separate. So what they're asking is that you are placing the, you can say, the 0 size blocks. That is query type 1. You are placing them whenever they are encountered. But you are not placing these. So these are not taking permanent space. You are just checking whether you can place it or not place it. Okay. So this is important. So what we are permanently concerned with is these one sized query blocks. So these will be placed. And if they come in between, so we can't place these type 2 blocks there. Now let us proceed how to solve it. See, we need to maintain, as we can see that we need to maintain ranges. And generally in range calculations, we need to, where the ranges are changing as well, the intuition is to use Fenwick trees or segment trees. Now segment trees are a bit vast implementation, and Fenwick trees are implemented have a slightly lesser lines of code and are slightly easier to implement. So in range calculations, for example, you need to maintain a range of, let's say, a sum up till a index, maximum sum up till a index. So you can maintain that using these things. Now, why not another data structures? For example, why can't we use, let's say, for maximum, we are using heap, or for map, we can use. We can't use them because we are not dealing with the whole size query at a time. we are dealing with partial query, and that is not possible in other data structures. Okay. So when we are dealing with some part of the query, so we need to divide it into blocks, and that is what a Fenwick tree do. Okay, so now let us see the code. I will first tell you so Fenwick tree implementation. You can see, let us see what these functions of Fenwick trees are doing. Now I have two functions here, update function and a query function. So what update function will do? Update function will update the value of the block with new maximum value. Okay. So it will update with new maximum value. And generally, when we are updating, we will see that only right side is affected. Right side is mostly affected if one of the block is updated. Okay. So what will a query have? What will a query have? A query will have the maximum value. Yes. A query will have the maximum block size, or in this case, block size up till that index. Up till that index. So let me write it will the maximum block size value up till that index. Correct? And update function will update the maximum value. So now we are clear with this. So let us see the approach. Now, first of all, we are using a set data structure. Set data structure is used to find out the previous and next position. So for example, if this is my and this is, let's say, and I am keeping an obstacle here. So this and this will change. So I need to have to know these coordinates. Hence, I am using a set data structure to mark positions. For what I am using? To mark positions and update. Okay, update we can also do that. Now, in this question, we are given that, okay, lower limit is 0, but upper bound is not given. But in order to calculate these distances every time without fail, we need to have an upper bound as well. So what can we do? We can check the constraints. So if we check the constraints, we will find that, see, x is the maximum coordinate size. So we will take according to this one, x, that is a minimum of 5 into 10 raised to power 4, comma, queries dot length. Because x is the maximum coordinate. So we will place an obstacle here and we will place an obstacle at position n. Now we will initialize the Fenwick tool. Now, first of all, what we are doing, just a second. Yes. So first of all, we are inserting all the queries, all the position of the type 1 queries into the set. So set will have all the positions of the queries. Fine. Next thing what we are doing is that we will build a Fenwick tree with initial obstacle gaps. Now, the approach we are taking is something like this. Okay, let me just explain you a bit about that approach. Let us say this is a number line and this this is 0. Yes, this is 0, this is M. Forget about these. So these are the blocks, uh total queries. These are total queries. Now what the question state is that For example, initially, these queries were not there. Initially, let us say these queries were not there. Only this came. So I had this as my empty space and this as my empty space. Now, if this query came, did this distance change? Did this distance change? No. Only this part, right side of that query was affected. So that is the logic. What we will try, so we know that right side is only affected. So we will try to keep initially all the queries and we will iterate from backwards. We will iterate the queries from backwards. Now I know that, okay, let me just take the example of this. Just a second. Yes. Yes. So this is one query. That means 2 is placed here. Now this query came. Okay, so for example, here is also a query, let's say 1 comma 3. Okay, let us say 1 comma 3 is here. So if I am processing it from the end, that means I am sure that 2 is placed at 3 position, block is placed, and I am now calculating. And I am now calculating. And once I calculated this and encountered this, that means this is over. So if I am at this one, so I know that only one block is there. But if I calculate from left to right, if I go from left to right, then okay, so I know that at 2 there is block and I can place it here. But in future, 1 comma 3, but in future there will be 3 here as well. Yes, but in future there will be 3 here as well, and that might affect my previous answer. So this is, we will move from backwards and we will remove the blocks once they are encountered. Now let us see the approach. So hence I am first of all putting all the obstacles on the Fenwick tree. All the obstacles I am putting on the Fenwick tree in this one. So now how will I update? I need to update, I need the index and I need the gap size. So index is the current index which will be given by set, and gap size I have to find using previous one, because previous one is placed. So this will be the gap size. Correct. Let us move forward. Update function we have already seen. Now we are traversing the queries. We are actually doing the queries. So in this, what we will do, just a second, I will clear up this. Yes. So we will traverse queries from the end. If the query is of type 1, if the query is of type 1, what we need to do? That means the right side queries, query 2, all the queries 2 have been processed. So I need to remove this. So now in order to remove this, see, if this is there, this is, let's say, previous, this is next. So then if I remove this, then this distance will change. These nodes distance will change. So that also I need to update. That also I need to update. And which node will be affected? Only next node. Only next node, right side node will be affected. Because what is a node saying? Node is a node query will give us the up till that index, what is the maximum block size. So only right side can change. So that is why we are updating the right side, next one, with a distance of this. I think this is very, very clear. Now, If the query is of second type, then what we have to do? We just need to find the upper bound of the position. See, what are we doing? We are trying to place them. We are trying to place it. We have the position. That means the maximum position. We have the size. So now I am finding the upper bound of that uh, position. That means the greatest bigger. And then I will take its previous value. And then I will take its previous value to something like this. For example, if this, and this, and let us say this is my x limit. So this will be my upper bound, and previous to that will be this. So what I will take? I will take an answer from here. I will take an answer from here, or this is as simple as that. I will take maximum. I can place it here as well, and I can place it here as well. So I will take the maximum gap, and I will check if maximum gap is greater than size, then I will place it. So is that clear how we are doing it? Let's say we had to place it here, then we found out this next one. Then through this next, we found out this previous one. You getting it? Then we checked it. Then we checked it, whether it is possible or finally we will reverse the results as we are processing it from right to left, and then we will return this. So yeah, guys, this was all from this question. Thank you so much, guys. We shall see you next time.